Yes. Yes. So shall we start?
Yes, let's start.
Okay, so hello everyone. Welcome to our Developers Technical Talk live session. We are so happy to have you here joining us. So let me briefly tell you more about our DTT Developers Technical Talk. So basically, our technical talks are designed to introduce Huawei cloud services. And in these talks, we are going to cover a wide range of topics, all related to Huawei clouds. So for today's session, we will explore Huawei Cloud Computing Fundamentals with Huawei Cloud Global Expert Zeynep Kucur. So you can share the link with your friends to join us as well. And let's all get ready for an insightful discussion. And feel free also to ask a question. And here is to the surprise. Stay tuned for our special giveaways along the way. So, hello Zeynep.
Hi, Kristen. Thank you for introducing me. I'm well. How are you?
I'm doing great.
Thank you. I would also like to welcome everyone to the first Developer Technical Talk session. Today, we will have an overview of cloud computing technology. And if you let me, I will start to share my screen now.
Sure, go ahead.
Do you see my screen? Yes. I would like to start the session by introducing myself first. My name is Zeynep, and I'm a cloud expert at Huawei Cloud. In today's session, we will explore the fundamental concepts, cloud service and deployment models, how cloud computing makes our lives easy, and basic Huawei cloud compute, network, and storage services. I look forward to a productive and engaging session where we all can learn and grow together. We have two sections. First one is cloud computing basics, and second is cloud computing technologies with an introduction to Huawei cloud services. Let's start with cloud computing basics, and I would like to remind you, like Kristen said, at the end of each section, we will hold a quiz, and the winner will win a surprise gift from us. Here is the foreword. We all know that rapidly growing information and communication technology companies have high requirements for cloud, compute, storage, and network resources. In this context, a new architecture has emerged to meet the need for on-demand resources to accelerate business innovation. This architecture is called cloud computing. We will talk about the background of cloud computing, proceed with the definition of it, understand that cloud computing is in our daily life, then learn about cloud computing models and its benefits. The information explosion is coming and is actually here. With the widespread use of mobile internet, more and more terminal devices are being used every day. There is a significant increase in the number of devices connecting to the internet, leading to an explosion of data. Challenges are emerging in traditional information and communication technologies, and traditional IT cannot cope with these challenges. As I mentioned, the growing popularity of the internet brings a large amount of traffic, users, and data to enterprises. To keep up with the rapidly developing businesses, enterprises need to continuously purchase traditional IT devices. Therefore, the disadvantages of traditional devices gradually emerge. Here are the disadvantages. The service rollout is slow because the procurement period of IT devices is long in traditional IT. There is difficulty in expansion because traditional IT has centralized architecture, and centralized architecture is poor in scalability. Reliability is low as traditional hardware devices are isolated from each other, and their reliability mainly depends on software. Lifecycle management is complex, as the devices and vendors are heterogeneous and hard to manage. And lastly, There's high TCO. When a device such as a server is not fully used, it means that the hardware's potential is not being maximized. For example, a server might be operating at only 20–30% of its capacity most of the time. In cloud computing, with its flexible on-demand resource allocation, this addresses these issues by ensuring high utilization and cost efficiency, because you can purchase things on demand and then leave them when you're not using them. So here's a discussion. How can IT enterprises overcome these challenges? If you have anything in your mind, please comment. I will tell you. IT enterprises must undergo infrastructure transformation, integrate resources comprehensively, and engage in collaborative work, continuous optimization to overcome these issues. We know that enterprises are migrating to the cloud architecture. The traditional IT architecture consists of hardware and software, including infrastructure, data centers, servers, network hardware, desktop computers, and enterprise application software solutions. This architecture requires more power, physical space, and money, and is often installed locally for enterprise or private use only. Virtualization technology, on the other hand, allows computer components to operate in virtual environment rather than a physical one, unlike the conventional IT architecture. Virtualization maximizes the use of physical hardware and simplifies software management. And what about the cloud architecture? Enterprise data centers are transformed from resource silos to resource pooling, from centralized architecture to distributed architecture, from dedicated hardware to software-defined storage mode, from manual handling to self-service and automatic service, and from distributed statistics to unified metering. These are the key features of cloud migration of enterprise data centers. We will continue with the definition of cloud computing. First, we should understand the definition. We know that cloud computing is considered as a model. It can obtain required resources like networks, servers, storage devices, applications, and services from the shared pool of configurable computing resource, anytime, anywhere, and on demand. Resources can be quickly supplied and released, minimizing the workload and managing resources and interaction with service providers. Therefore, you don't have to worry about the total cost of ownership. According to Wikipedia, cloud computing is the on-demand availability of computer system resources, especially data, storage, and computing power, without direct active management by the user. Cloud computing is not a technology but a model, which allows users to use resources such as networks, servers, and storage devices. These resources belong to the IT domain. It aims to enable the public to access IT services as if they are water and electricity. Let's continue with how cloud computing is in our daily life. We actually all use cloud computing, but do we know that we actually use it? For example, as you see, there's cloud albums, cloud music, cloud videos, cloud documents. For example, you must have a cloud album in your phone. We all, we don't always locally store our photos. Cloud album is an album stored in the cloud. Users do not need to worry about losing their photos due to mobile phone loss. So if you lose your phone and if you backed up your photos to the cloud album, you can reach those photos anywhere with any device that has a connection to the internet. And next, cloud music. Music software applications has become an essential part of everyone's life. We all listen to music, but do we store all the songs that we like? And is it possible to store all the songs we like in our phone? So we use cloud music applications which use cloud computing. Next one is cloud videos. It refers to the video network platform services based on the cloud computing business model. Like cloud music, users can play videos without having those videos locally. Another great example is cloud documents. For example, users can directly create online documents to facilitate editing and viewing on multiple devices. You don't have to have those cloud document applications in your computer either. You can, use them online and store your documents online. Let's continue with cloud computing models. Deployment models for cloud computing. There are private, hybrid, and public cloud. What are the relationships and what are the differences between them? First, let's talk about deployment models, starting with the private cloud. The private cloud is usually deployed in an enterprise or enterprises. Data running on the private cloud is stored in the enterprise data center. If the data needs to be accessed, the firewall deployed at the ingress of the data center is required to protect the data to the greatest extent. And second one is public cloud. A public cloud is a cloud computing model where services and infrastructure are provided by third-party operators over the internet, available to the general public or large industry groups. Users can access and use IT resources on a pay-as-you-go basis, benefiting from scalability and cost efficiency. And the third one is hybrid cloud. It is a cloud computing environment, and it combines both private and public clouds together, allowing data and applications to be shared between them. It provides greater flexibility and optimization by enabling users to switch services and balance workloads across multiple cloud platforms. Let's continue with service models for cloud computing. Here we see traditional IT, infrastructure as a service, platform as a service, and software as a service. In the traditional IT architecture, users need to purchase all the hardware and software devices by themselves. Therefore, they need to manage all the hardware and software devices by themselves. In infrastructure as a service, which goes by IaaS, cloud service provider is responsible of maintaining related resources. For example, Huawei Cloud is one of the cloud service providers in the world. And in infrastructure as a service, they're responsible for maintaining the related resources. Users need to pay attention to the systems and application layer in infrastructure as a service. On the other hand, platform as a service, such as servers, storage, network, and virtualization resources, also the environment required for application running. For example, the environment like operating system, here we see it, the middleware and software, running environment, and maintaining related resources. They are included in platform as a service. On the other hand, in software as a service, which is the one that is most covering, the cloud platform provides all resource services and maintenance. Users only need to use applications and do not need to worry about the rest of the things that I have mentioned. I can sum up that compared to traditional IT procurement, the cloud service model sells IT equipment. As a service, allowing customers to select as required, which is more flexible and cost-effective than traditional IT. We all use software as a service applications in our daily life. For example, our mailing applications, the social media accounts, they're all an example of software as a service. And I would like to show you Huawei Cloud. Our official website is huaweicloud.com. Huawei Cloud is a public cloud service brand. It's one of the biggest in the cloud providers in the world, and it leverages Huawei's more than 30 years of expertise in the ICT field to provide innovative, secure, and cost-effective cloud services. We have launched more than 220 cloud services and more than 210 solutions. You can see our compute services here, network services, enterprise intelligence, management, and then application services, storage, security, cloud meeting, hybrid cloud, IoT platform, databases, video, containers, and software development. And what about the benefits of cloud computing? Cloud computing integrates hardware resources into a whole software mode and then dynamically allocates them to applications, which greatly improves resource utilization and elastic capacity expansion. Therefore, cloud computing has the following 5 benefits. On-demand self-service. Users can provision and manage computing resources as needed without requiring human intervention from the service provider, which provides flexibility and control to users, allowing them to quickly scale resources up or down based on their needs. And then the other one is broad network access. Cloud services are accessible from any device with internet connection, enhancing accessibility and supporting remote work. And then there's resource pooling. Different physical and virtual resources can be dynamically allocated and reallocated based on customer requirements. The customer does not need to know exactly where the resource is. It can be anywhere in the world if you have a region there. For example, Huawei Cloud has many regions around the world in different countries. So you can purchase your resource wherever you are based on the latency you want. These resources include storage, processors, memory, network bandwidth, virtual machines, and more. Quick deployment and auto-scaling is the next benefit. Cloud computing resources can be quickly expanded or released to achieve quick scaling. For example, you are hosting a website and you have lots of traffic and you're afraid that you're going to crash because of this traffic. For example, big enterprises, for example, during 11/11, they have lots of traffic and they need to scale out so that they can serve properly. They use cloud computing so they can respond to this demand. And last one, metered services. Cloud services are charged based on the actual resources used by users, such as CPU, memory, storage capacity, and network bandwidth consumption. It can be charged by hour or yearly or monthly. If you select the hour option, you are charged by the hour you use. I would like to ask my friend, do we have any questions before we proceed to our quiz?
For now, no, but I think that we can proceed with the next part.
All right. So our next part is the most fun part, I guess. We have 2 questions about cloud computing basics. And we have learned so far. If you want me to, repeat something so you can respond properly again, I can show you quickly our sections. We talked about the background of cloud computing, where it stemmed from. We said that traditional IT couldn't keep up with the challenges brought by the amount of information we have right now. In 2024, we use IoT devices. We have lots of users in the internet, and every day people are joining internet and creating data. And we need to process this data. That's why cloud computing is needed. Another one, definition of cloud computing. We talked about the definition of cloud computing, and we said that it's the ability to be able to use compute resources, storage resources, and network on demand. And then we talked about how cloud computing is around us. We gave examples that we said that, the applications we use actually use cloud computing. For example, the music applications, the video applications, they all use cloud computing, and it is around us even if we don't know that we use it. And then we talked about the models and the deployment models. We talked about benefits of cloud computing. So I would like to show again the cloud computing deployment models. There is private, public, and hybrid cloud. We said that private cloud is the cloud infrastructure is provisioned for exclusive use by a single organization, and public cloud, the cloud infrastructure is owned and managed by a third-party provider and shared with multiple organizations using the public internet. Huawei has public cloud, and you can use it when you go and purchase our cloud resources on huaweicloud.com. It is public cloud. And then there is hybrid cloud. This is a combination of public and private clouds viewed as a single cloud externally. And then I talked about service models for cloud computing. I said there is IaaS, PaaS, and SaaS. IaaS stands for infrastructure as a service, where the cloud provider is responsible for network, storage, server, and virtualization. In platform as a service, the cloud provider is responsible for network, storage, server, virtualization. And on top of that, the difference from IaaS is that they also manage the operating system, middleware, and runtime environment. And in software as a service, the cloud platform manages the whole thing. For example, I said the applications that we use, like a music listening platform or a video watching platform, they're all examples of software as a service. Now, after repeating and giving you a brief of what we talked about, I would like to proceed with Kahoot. We have 2 questions there. I will show you how to register to Kahoot and how to play the game. This is the first round. Okay. Please get ready to join. I will give you 5 minutes so everybody has time to get in. You can open your cameras, and then you have to scan the QR code. And if it is not possible for you to scan the QR code, you can put this game pin, which is 8414842. I will be waiting for you. The winner of the 2 rounds, they will receive a surprise gift from us. So I encourage you to play. And please register with the name that you want to receive the gift with. We will ask you to confirm your ID. You can reach us on our social media accounts by WhatsApp group. You can text us on our WhatsApp group, and we will show you a QR code to join our WhatsApp group at the end of the session. So we have a few more minutes left. Yes. We can join from our phone, and also we can join from our browser. You can put the game pin, and then you can join from the browser. You have to type in Kahoot. You can Google Kahoot, and then you can put the game pin to be able to play.
So Zeynep, can we give them like a few more minutes or a few more
Yes,
seconds?
I can. If anybody is having a hard time, we can wait how many minutes more? 5 minutes more.
Okay, we will wait for 5 minutes more, so you still have time to register. And if you're still facing any issues, you can like mention those on the comment section.
Has anyone played Kahoot before? Claude Enginarı commented that can we wait, and we are waiting, don't worry. We're waiting a few more minutes if we're not ready. I see that 23 people registered already, and this is a good number. I'm excited for the game. Okay, if anybody, I see Mai. Can Mai comment in YouTube with their, long name and surname, and the DT with name and surname? And there's Berkant and Seni Seviyorum. Can they please, mention their name and surname? So if you win the gift, we are able to, know who you are and be able to send you the gift. $25. There are still people who are joining, so I will wait a few minutes more. Okay, Berkant, we're waiting. If you can't change the name, Dilek, you can mention what name you typed there, and then we know. All right. Okay, does anyone else want me to wait a few minutes more? If you're all ready, I can start in a minute. I will start in a minute. Room K is known as Kate Lam, and Dilek Doğan Kollu is Dilek Doğan Kollu. I think everybody is ready. So shall I start the game? What do you think, Kristen?
Yes.
All right.
I cannot wait.
Let's start. First round, cloud computing. Which one is not a deployment model for cloud computing? Okay, 18 people responded correctly, and there are 7 wrong answers. Next question. We see the highest score goes to Mustafa Tarek, and then Mohammed Emin. We are proceeding to the next question. I hope you're all ready. Which one is not a service model for cloud computing? Infrastructure as a service, platform as a service, database as a service, or software as a service? We have 19 correct answers and then 12 wrong answers. Let's see who is the winner of the first round. The third is Onur Çetin. Second is DT. And first one is Mustafa Tarek. Congratulations, Mustafa. So Mustafa Tarek will receive a gift from us. And the other people who are upset that they couldn't win, you should try for the second round, because we will have a second round. I will continue with the presentation. Ceren, don't be upset. You can win the next round. All right. So we have the second section. The second section is about cloud computing technologies. Here is an overview. Cloud computing consists of three fundamental contents. First one is compute, second one is network, and the third one is storage. We know that compute services provide the computing power required for running services such as websites, office software, and data analysis. Compute includes virtualization and container technologies. Networking products, on the other hand, include traditional networks and virtual network technologies. Network services provide resource connectivity and isolation, such as data center networks and campus networks. On the cloud, virtual machines use virtual networks. For example, in Huawei, virtual private cloud. Those have a logical topology similar to that of traditional networks. The third one is storage. Storage includes block storage, file storage, and object storage. Traditional servers have computing and storage coupled and use their local physical disks to store data. This is what we call traditional block storage, where a disk is connected to a server through a bus, which delivers low latency. However, the number of disks that can be attached to a server is limited. As IT systems develop further, enterprises want their files to be shared among multiple hosts for concurrent access. This is called shared file storage. And on the other hand, object storage. We know as more and more internet applications need to access data over the internet using terminal devices. Object storage supports HTTP and HTTPS protocols. Object storage allows applications to access data by calling APIs and adopts a distributed architecture featuring large capacity and high reliability. Then what is virtualization? How is cloud computing supported? You know, the base of cloud computing is virtualization. Virtualization is the process of creating multiple independent virtual servers from a single physical server. Generally, an application can run only after it is installed on an operating system, and a physical server can run only one operating system at a time. But by dividing the physical resources into multiple virtual servers, each with its own operating system. By that I mean that when you create multiple virtual servers, each virtual server has their own operating system, and in this way you can run multiple operating systems on the same physical server. So you have one physical server, and with virtualization you can have virtual machines, like several virtual machines in a one physical server, and each of those virtual machines can have their own operating system. And you can isolate these virtual machines from each other with virtualization technology. When multiple programs are running on the same operating system of a physical server, there can be application conflicts and performance problems. Only running a single program on each server would address this problem, but could end up wasting a tremendous amount of resources. So imagine you use a different physical server for each application you have. Imagine how much of a waste that would be. The utilization rate would be low and everything. And with cloud computing, we are, ditching those disadvantages, and we are reaching the maximum efficiency that we can have. So with virtualization, multiple virtual machines can run on a physical server, and each virtual machine runs its own operating system, and this improves hardware utilization. Like you see here, the key concept behind virtualization involves separating software from hardware by converting these physical devices into logical folders or files. Let's discuss the difference between virtualization and cloud computing. It is not entirely accurate to separate these two terms because cloud computing is a methodology based on virtualization technology. We cannot imagine cloud computing without virtualization because virtualization is actually the base of cloud computing. Virtualization is the process of converting physical hardware into virtual environments. Cloud computing, on the other hand, is a service that provides virtualized resources on demand over the internet. You can use cloud computing resources with a device that you have a connection to the internet. And here are the important virtualization concepts. Here we see a depiction of physical server and a depiction of a physical server with hypervisor layer and a guest machine inside. This physical server can have multiple guest machines if you want to create more, because there's hypervisor layer which enables this. We see here a hypervisor is a layer that enables the virtualization of a physical server, and this layer abstracts the physical server's hardware resources and allocates them to virtual machines. Basically, hypervisor is used to create and run virtual machines on physical servers. It sits on the software layer between a physical server and an operating system. It allows multiple operating systems and applications to share the same physical hardware. So here, each guest machine actually shares the same physical server of a single machine. And if you excuse me, I need to drink water. Hypervisor also has a different name. It can also be called virtual machine monitor or virtualization software layer. Guest machines are called virtual machines, which is called VMs. And guest operating systems are called virtual machine operating systems. And the host machine is mainly referred as the physical machine. The physical server you have is called the host machine. And the host operating system is actually the main physical machine's operating system. And I would like to briefly talk about the Huawei Cloud Compute Services. I will briefly mention them now, but next week and the week after, we will mainly talk about Huawei Cloud Compute Services, storage services, and network services. Let's start with what a compute resource is. We learned that a compute resource is a measurable amount of computing power that can be requested, allocated, and used for compute activity. Common computing resources include CPU and memory. A computing cloud service is a service or a product that can provide computing resources on the cloud. So let's continue with the basic Huawei Cloud Compute Services. Here we see ECS. It's actually VM in essence. So ECS is when we talk about virtual machines, you can go on Huawei Cloud and then you can purchase an ECS if you want to have your own virtual machine. So what it does is there's a physical machine and it has a virtualization layer, and with virtualization layer they make it possible to have many virtual machines, and you can actually select the amount of CPU, memory, and the type of operating system you want to have. You can attach disks, we call them EVS. And after buying an ECS, you can use it on the cloud just like you would use your local PC or your physical server. And then there is auto-scaling. Auto-scaling automatically scales compute resources based on your demands and the auto-scaling policies you have configured. So let's say you have lots of traffic coming and then you have multiple elastic cloud servers. By that, I mean many virtual machines. You can, configure auto-scaling in such way that you say, if my CPU goes above, 70%, I want to have more, compute power. So you trigger to have another ECS to support you with your workload. So you have to properly adjust the number of ECSs as the service load changes over the time. Sorry. And when we come to the other compute service, which is image management service, An image is a template used to create servers or disks. So if you have an image, let's say you created an image of your ECS, and you can, use that image with your auto-scaling policy to, when you trigger, your policy gets triggered, and then you have to create another ECS. That ECS can be created with the image you took of the ECS you have now. So with the IMS, you can create a system or data disk image from a server or an external image file, or create a full ECS image from an ECS or a backup of an ECS. An image in computing refers to a snapshot of the state of a system, including the OS, application software, and data. So let's say you're maybe thinking about, oh, I have this application in my ECS. If I take an image of it, will it still be there? Yes. In the context of cloud computing, an image is a virtual representation of a computer system, including its operating system, applications, and data, that can be used to create a new virtual machine instance. In this, by virtual machine here, we mean the ECS. An image can be stored in cloud providers' image repository and used as the basis for launching new virtual machines, like I talked about. This allows for consistency and standardization across virtual machine instances, making it easier to deploy, manage, and scale cloud-based applications. Now we continue with Huawei Cloud Network Services. VPC. VPC is a private and isolated network on Huawei Cloud. So just like you have your network in your traditional enterprises, traditional IT enterprises, in cloud you have virtual private clouds, virtual networks. And here users can configure IP address ranges, subnets, and security groups, assign EIPs, and allocate bandwidth in a VPC. Net gateways provide network address translation. In net gateways, there's SNet and DNet to allow cloud servers in a VPC to share elastic IPs for internet access while maintaining security by isolating internal IP addresses from external exposure. Let's say in the subnet, in your VPC, you have multiple resources, and then you don't want to, attach EIPs to each resource. You can use Net Gateway to, assign a single EIP to each source. And then, as I mentioned, the elastic EIP, the elastic IP is the independent public IP resources for ECSs. The EIP service provides independent public static IP addresses and bandwidth for internet accesses. EIPs can be bound to or unbound from ECSs, BMSs, which is a bare metal server. And let's say you want to buy your own physical server, and but you want to ditch it at the time that you want. Let's say you want a physical server for 2 hours, you can buy a bare metal server. You can attach EIPs to it. You can attach EIPs to your load balancers and then your net gateways. And then the last one, we have learned the mainstream storage types. They were block storage, file storage, and object storage. Here, our virtual block storage is actually EVS. It's called Elastic Volume Service. It provides block storage space for elastic servers elastic cloud servers and bare metal servers, the BMSs that I just mentioned. You can choose these types based on your needs and store files and build databases on EVS disks. It can be dynamically resized and provides data backup and disaster recovery capabilities to ensure data availability and reliability. And the other mainstream storage type was file storage, and here we call it scalable file service. Scalable file service is the cloud solution Huawei Cloud has for the file storage, as I said. It is designed to provide a shared file storage system for cloud servers, including both elastic cloud server and bare metal server. SFS allows multiple cloud servers to access and work with the same file simultaneously. Let's say you have multiple ECSs and you configure the scalable file servers. They can reach out to the same document at the same time. This is like having a single library where multiple people can check out and read the same books at the same time. And the last storage service that I will mention is the object storage. OBS is Huawei Cloud's object storage solution. It offers reliable, high performance, and secure storage for data of any size and type. It is ideal for non-transactional static data, such as archives, backups, large file sharing, scientific research, and digital media like photos and videos. And in fact, in China, they use OBS to back up their phones, back up the pictures that they took. And this is our second round of questions. We will have another Kahoot, like I said. And, you know, if you want me, I will go through the things that I mentioned so you can be more ready for our Kahoot. If you don't mind me. Here in the second section, we talked about compute, network, and storage. We had an overview. We said in compute, there is virtualization and containers. In network, there's classic networks, virtual networks. In storage, there's block storage, file storage, and object storage. We talked about virtualization and what enables virtualization. Then we mentioned that cloud computing cannot be imagined without virtualization. We talked about the important virtualization concepts. We talked about what a guest machine is, what a physical server is, the differences between them, how to virtualize a physical server. We said that the hypervisor what makes the virtualization possible. That hypervisor is also called a VMM. A host machine is running on a physical machine, is the virtual operating system. Sorry. The guest OS is the virtual operating system, and the host OS is the physical machine's operating system. Then we mentioned Huawei Cloud's compute services. There are ECS, auto-scaling AS, and then image management service, IMS. Then I mentioned network services, which is virtual private cloud called VPC, NAT gateway, and elastic IP. And then there's elastic volume service, which is a storage service, and then scalable file service and object storage service. So I will open the next round of Kahoot. Please be ready. Here is the pin. If you cannot open from your phone, please open the website of Kahoot. I will wait 5 minutes. We also have 2 questions here. Like I said, please register with your real names. Yes, Mustafa, you can join. So I will wait 2 more minutes. There are 2 questions, Dilek. 23 of you has registered. I will wait for 2 more minutes. So if you're all ready, all right, I think you are all ready, so I will proceed with the game. Let's start with the second round. Which one is a Huawei Cloud Compute Service? Sixteen of you has responded correctly. Well, ECS is a cloud compute service. I mentioned that it is the virtual machine solution of Huawei Cloud. And OBS and EBS and SFS, there are the storage solutions. OBS is for object storage, EBS is for block storage, and SFS is for file storage. Let's continue with the next question. And first, we will see who won this first question. Necati Tetik. Congratulations for the first question. And the second question, what enables the virtualization of a physical server? Congratulations to all of you who responded correctly. Hypervisor is the virtualization layer of the hypervisor makes it possible to virtualize the physical server. So virtual machine is the the machine. When we virtualize the server, we can have virtual machines. Operating system can be it's the operating system, and container is a computing technology. Let's see who won this question and who won the whole thing. Mustafa Tarek is the third one now, and Dilek is the second, and number one. Necati Tetik, congratulations. We invite both of you, the first round winner and the second round winner, to reach us on our social media WhatsApp. I will show you the QR codes now. Well, first, I would like to say thank you all for joining us today. We have covered a lot from cloud computing basics to basic Huawei cloud compute, storage, and network services. We hope you gained valuable insights. Remember, this is just the beginning of your journey with Huawei cloud technology. If you have further questions, you can reach out on our WhatsApp group. Also, make sure you are following us on social media. Until next time, stay curious and keep innovating. And like I said, here is our WhatsApp QR code. You can scan it, and then the winners of the first 2 rounds, they can text us on here. And wait for your surprise gift. And Next week, we will have another session, and the next week's session is about Huawei Cloud, Compute, Storage, and Network Services. So stay tuned, and thank you for listening to us.